Hello and welcome to final section of this course. In this section, we'll look at a real-life application of numerical methods. For example, we are told that the price of a car in X years after the purchase is modeled by a function f of x. F of x is 15,000 multiplied by 0.85 raised to the power of x. Take away 1,000 sine x. X is always positive, and x is of course the time in years. So the question in part A is asking us to use the model to find the value of the car after 10 years. That should be easy piece of work. By substituting 10 for a value of x, we will evaluate the function and the result is easily found. Pound values are rounded up to two decimal places so that we give our answers close to two decimal places. In part B of the problem, we are told to show that f of x has a root between 19 and 20. Practically, what it means is that the value of the car will reach zero at some point between the 19th and 20th years. But for our purposes, we will find the root by substitute. We will not find the root. We will show that the root exists in this interval by the change of sign formula. So all we have to do is substitute 19 into it and we get a positive answer. We'll substitute 20 into the function and we will have a negative answer. The change of sign is good enough to show that the root lies within this interval. We will have at least one root, or it could be more than one root, but that's not the question we are asked to find. Let's read the next section. We are told to find the derivative of the function. The derivative of original function. So we have to be very careful because x is the power of 0.85. The number 15,000 is simply a multiplicative constant and that will remain as it is. If we think back to what we learned in previous chapter, namely chapter 9 when we learned differentiation, where we have exponential functions, we will have a logarithm in the answer. We will have to multiply 15,000 by log of 0.85 and repeat 0.85 raised to the power of x in our answer for the derivative of the first term. So what you see here is simply the first, only the first term uh, that is being found to have its derivative. Now we're going to look at the derivative of negative 1,000 sine. Negative 1,000 is a constant and it will remain as it is. Derivative of sine is cos, so we'll have negative 1,000 cos x. In part D, we are asked to take 19.5 as our first approximation and apply the Newton-Raphson method to find the second approximation for the time when the value of the car reaches zero. So we already have the derivative function. That's great. We are going to use it for this part of the problem. We will store 19.5 in our calculator as the first answer. We will substitute it into the equation. This Newton-Raphson formula is on top corner of the page, top left corner, but you can also find it in the formula booklet if you are stuck in an exam situation and you're panicking. There is no need to panic. So the first iteration will give us an answer of 19.528. So we actually use 19.5 as our first approximation. So we only need to repeat this function once and there is no need for second and third iteration because we have already got what we're looking for. So part E of the question is asking us to criticize the model with respect to the value of car as it gets older? Well, the function will have negative values, and value of a car will not be negative at any point beyond a certain point. So that point where 19.5 is just over 19 and 6 months. So after that, the car value is not appropriately approximated with this formula. So after around 20 years old, car will not be working with this function. All right, happy practicing, and I'll see you in the next section of the course.